Good morning. Morning, engineers and people.
Good morning, engineer.
How are you?
We're doing great over here at our end, actually. How are you?
Good. We are ready here to kick off. Okay, I will share my screen now. Okay, so I have tried on my end also to model the project. Okay, so I will ask every one of you, please, to stop what you are doing. Stop modeling. What you have done is enough. Okay, because now we are going to go in the analysis part, and it is more of theory. Okay, it is more of theory. It means you need to follow. Okay, so because I will be explaining many kind of settings, so you need to follow to understand what all those settings are for. Okay, so if I try to explain a bit about what I have did on my end, you can see it is the same model that you have. Okay, if I maybe open the plan view, you will see that it is the model. Okay, and I have tried to apply the load. You can see this red. Okay, we have walls here. We have the staircase here. You remember how? Let me try to tie my view so that maybe it will be much clear to you. So this is the model that we had. Okay. So what I did first was to create the grids. Okay, so try to create the grid so that the grid from the architecture side are similar to the structure. So in case you see that those one created by the structure, the architect are needed. So I tried to imitate the grids, but I had to add my own grids, because you can say I have offsetted this grid 6. Okay, there are also other grids that I inserted depending on what I want to achieve. Okay, but you see it is the same model. Okay, so you can see for my plan here, so it is this one. When you are creating the columns, okay, you must take a look to the ground floor. Okay, so those columns, okay, to know where you have to locate columns. But when it comes to modeling beams, you have to shift to the first floor, because the beams we'll be modeling here will be carrying the walls which are on the first floor. So when I modeled the beams, I take reference to the first floor, not the ground floor. Okay, so I came here. Now I try to put the beams and the wall loads. Okay, so you can see this is the first room we have here. Okay, these are the verandas, yeah, that we have here. You can see I have this like this L shape here in this corner. We have loads. You can see it here. We have masonry walls, okay, which are going all the way up to the other story, if I can say so. If maybe you double check, it is this one. So this wall is going all the way up, but we have another small like balusters here. So that's why on my end here you can see all the walls here, and the balusters I have also added them here. So if I view it in a 3D view, it is this area. It is like looking like this. Okay. So we have the staircase, which we have here as well. Then I had this toilet. I have a toilet here. I have opening on this wall. I have another opening somewhere around here, which is these two openings. Okay. So if I click on this, I click on this and go to edit load, you will see that my wall have opening as well. Okay. So if I click on this beam, go to edit load, you'll see the opening is there. Okay. So if I go to the 3D view, I will temporarily hide the upper floor. Okay. You see, it is this one here. So we have the door, which is this one. We have another one here for the toilet. We have the window for the toilet. And if I pass here, I will go to the main room, which is this one. Okay. Good. And here we have the last toilet, which is this one. Okay. There is a gap here because we have a column part which is rating here. Okay, so you can see I have tried to put all the loads. Okay, so that's what you will have to do. Okay, so that's it. I was just trying to show you how you will complete your model, the end. Now let's go on with the analysis. Okay. Because today we are concerned with the analysis. So far we dealt with the first 4 tabs. Now we are moving to the analysis. So before going to the analysis, you remember you have to check. Okay. So I didn't check. So I will do the building model check. I have no error. So if I open the 3D view to double check the design status, you see nothing is designed yet because I didn't run any analysis and design yet. I can see that all my model have one type of column. Okay. When it comes to beam section, I have only one type as well. When it comes to wall type, I have two type of walls. I have the one with 150 millimeter and another one with 250 millimeter. Okay, so those are the partition walls that I have assigned. When I come to the slab additional dead load, I can see it is 0. It means I didn't assign any slab additional dead load. So I can see that I have to do that before going to the analysis. That's the main point, that's the main reason of doing a review before. Okay, so I directly through the colors, these legends, I can know that I didn't assign any additional dead load. So if I go to the live load, you'll see also I have 0. So it means I have no assigned the additional dead load, even the live load. So I will do it very quickly. Go to the loading, to the slab additional dead load. I will click, maybe add it, create a new one. Okay. Maybe it will be composed by, let's say, tiles. Okay. I will apply tiles to the floor. And I will apply, let's say, still in grout, let's say. Good. So the remaining things will be to apply them to the slab, okay? So what I will do, I will right click, use the member table. It will be the quickest way. Go to slab table. And I will make all story are checked. For the additional dead load, I will add, you have to select the column first, select the column wise, and then I'll select the one that I created, click OK. Then for the live load, I'm going also to apply a one, which is a general domestic use. Then now it is assigned. So I can see for the live load, I have the values here, 1.5 for the additional slab, additional dead load, or the slab have this one, okay? So if I wanted to differentiate them, okay, then I would have done so. Maybe you can come here and say that because you know this slab is for the toilet, you will come and assign live load for toilet and whatever. So you can do that if you wish. So that's it. Now the review is done. I know the loads are well assigned. Then I will go to the analysis. So going to the analysis, we have the building analysis. So we have different type of analysis here. We have the normal building analysis here, okay? And you have the finite element analysis. These three icons are for the finite element analysis. So for what is supposed to be taught here, it is the building analysis. So we are going to go through the building analysis. So I will ask you all to open your building analysis so that you, when I will be explaining these settings, you will be able to see it on your screen very easily. Okay, so the building analysis tab have different tabs here at the top. You can see the pre-analysis, we have the model option, analysis tab, post-analysis, and reports. So we are starting with the first one, the pre-analysis. Okay. The pre-analysis, as you can understand, it is like settings that you have to set before running the analysis. So please follow here. Under the project parameter and loading, for my case, I have three options. I have setting center, loading combination, and wind and solid loads. Okay. So if I click on the setting center, it will open the general settings that you know. You are already familiar with these settings. It is similar to the one we opened using this icon here at the top. Okay. However, if you open it using the setting center, it will direct you to the code option. So you have a list of the code or the standard. Okay. The ones which are here by default are the ones you selected when you created the project. You remember when we were creating the project, you have to choose the code. I choose the British standard code. That's why I have the BS code inside here. But you are free to change if you want. So if, for instance, I come here to the concrete design code and click there, I'll see a list of all the available code. Then I am able to change the code. Okay. So I will cancel. I don't want to change any code here. Then I will click on OK. Okay. Simply, this setting center will allow you to double check the code that you have selected before going for the analysis. So in that case, you know which code, which standard you are using. Then the next one is the load combination. Remember yesterday we skipped this load combination. Click on load combination. You remember when we first created Slab, we had this load combination editor. So I told you to just click on OK so that we will have enough time to discuss about it. So the time is now. Okay, so if you go to load combinations, you have this table. So what we need here is to create the load cases and load combinations that will be used in the analysis and design. Okay, which will be used in the design. So to set those combinations, you have to go to the loading generator. Click on load generator, then you have another tab here. So we are going to see everything here. Good. So to start explaining, I will for now skip these three first options. I will come back to it later. Okay. Good. So the next one, we have vertical load combinations. We say tab here, and horizontal load combinations. Okay. There are two tabs here. So as you know, we have different load cases. So we have the vertical ones and the horizontal ones. Among the vertical ones, we have those gravitational loads. Okay. The live load, the self-weight, okay, and so on. Among the vertical ones, we have like wind loads, seismic loads, and so on. Okay. So question online. Okay. So can you repeat in load generator? So simply, I passed through the loading generator. The load combination button here. Okay. Then I use the loading generator, to have all these settings. So we are going to set the settings here. The settings we will be setting here will affect the load combination that we have on this list here. Okay. So that's what we are doing. Just click on loading generator. You'll have this box. So let's start with the vertical load combinations. You will see we have dead loads, we have live loads. Okay. So if you try to untick one of these, you will not be able to deactivate any of these, because in any case we always have the dead and live loads. Okay. So it is a must be there. Good. So talking to these dead and load and live load cases, depending on the standard you are using, depending on the code you are using, you have what we call safety factors. Okay. So for my case, I'm using the British standard. That's why here you will see I have 1.4 for the dead load and 1.6 for the live load. Okay. So if you have selected another design code, you will see different load combinations. So these are default, the ones which are recommended by the code. Okay, that's why they are automatically fit. So for instance, don't do this. If I click on OK, you will see the load combination created is 1.4 dead load plus 1.6 live load. Okay, so these factors have been used. Okay. So the next one is the define pattern load. Okay. So we will not cover these pattern loads. Okay, because It is more used when you are you want to see the how your structure is behaving, okay, on different scenario when it comes to the loading a continuous span. So if I give you like an example, if you see the first row that we have here, you have two equal sign for the first span. Take it as one span. So the next span we have the underscore, okay, here. The next span we have the equal sign again, and so on. So what it means, where you have an equal sign, it means we are considering that that span is fully loaded, is loaded at maximum, okay? Right? Where we have the underscore sign, it means that span, which is the next span, is partially loaded. Okay. So these are concerned with live load only. So let's suppose we are sitting in this room. We as humans, even these tables and the desk are live loads. So you may have another room on the next, on the adjacent to this room. So you may want to analyze a scenario. Maybe let's take an example for a BIM, where this first room will be fully loaded with the maximum live load, but the next one is not fully loaded. Okay. So if you want to see how that BIM will behave in that condition, then you will check this first option, and in the analysis we will have those results. Okay. So for the second, for this one here, for instance, it means we have two span with equal sign. It means two adjacent span are fully loaded, then the third one is partially loaded, and so on. So mainly, to cut it short, these settings or these parameters here are used to analyze to see how the behavior of your structure how your structure will behave. Okay. So for our case, because we are doing the initial design of a new building, it is not as much as important to take into account this. But sometimes you may have maybe an existing building, okay, and you want to investigate how loads are affecting those existing building. Now, in that case, we take into account this, so to see different scenarios which can happen. Okay. So, if you see, well, if I check this, let's say these two, and click on OK, I will have additional load combinations here. So remember, at the first point, I had only the first one, but now I have two others. Okay. So please note that having many load combinations doesn't mean having accurate analysis. Okay, so it's a matter of just understanding what you want to analyze, what you want to achieve. Okay, because at the end of the time, okay, what the software will do, it will analyze your building according to each load combination that we will be creating here, but it will design your member taking the maximum one. Okay, so if the first one is the maximum, it is providing the maximum loading, then the design will be considered using the maximum. So that's how it is. Okay, so we are done with this. So you will see the three next options: define load combination for roof, snow, and rain. Okay. So don't do this. Coming, just a minute. So you remember when we were in the loading of the slab? Okay, we have roof load, snow load, and rain loads, but they were deactivated. You cannot input value here. They were deactivated because here in the load combinations here, they were not activated. But if I activate this, click on OK, OK. Now the next time I will be loading the slab, now I will be able to put the value here. Okay, so if you are working on a project where these loads are being considered, then you have the ability to put them there. Okay. So for our case, we are not considering any of these load cases, so I will deactivate. Okay. Are we together so far? So let me finish the vertical load combination, then I will take questions before going to the horizontal, right? Okay, good. So we have other other type of load cases. Okay, we have stage cases and thermal loads. Okay. Still, as we are on our training, we are dealing with intermediate level of the training, so we not go through these advanced load cases. But just know that Protastructure can take into consideration, can analyze using these load cases as well. Okay, so now for our case, we are only dealing regarding the vertical load combination. We are dealing with the live and dead loads. Okay. So, is there any question regarding the vertical load combination before we go on to the horizontal load combinations? There is a question online. Write it down. Okay, so there is no question here. So then let's go on with the horizontal load combinations. Then I will move to the horizontal load combinations. Okay. So for the horizontal load combinations, also we are not going to consider this in this training, but it is necessary that be aware that the software also can consider these horizontal load combinations. Okay, the first one is the seismic load, and for my case it is deactivated. I cannot activate it. Okay, it is deactivated because when I was choosing the standard, the code to be used, I didn't check any seismic code. So if I go back, no need to go back on your case, just for the demonstration here. You remember under the code settings, under the earthquake code, I don't have any code. If I click there, you see, don't use seismic code was checked. But if I decide to use any, to select this code, click OK. Now, if I go to the loading combination, loading generator under horizontal, now seismic will be able to be checked and set the parameters for the seismic analysis. Okay, so we are not also dealing with earthquake. Another thing, if you select the seismic, you want to design the earthquake, so you will have these seismic parameters here. It is another option which will be added. So you'll have to pass through this, where you have to set all the settings related to the seismic here. Okay, good. So we are not going to see this, okay, but just know that it is available. Okay. Even wind load, we not consider wind load as well. So I'm coming back. So these notional load and wind loads all are horizontal loading. We are not going to see this, but the software can support that. We have also soil pressure. Soil pressure also is considered in lateral loading. So in case you have to consider any of these lateral loading, it's a matter of coming here, check it, set the parameters here. In that time, if you click on OK, the software will create the load combinations automatically. Okay. So for instance, if I check all of this, just to show you, okay. Click OK. You see now the load combinations have been created according to what I have selected. But remember, remember that the design will be carried according to only the maximum value. Okay. Even though I have around 40 load combination, the software will pick only the maximum and will be used in the design. Okay. So that's it about the load combinations. So please make sure that nothing is selected in the horizontal because we are not considering a horizontal load combination. Make sure that only the live and dead load are checked here. Okay. Good. So that's it about it. Now let me come back here and explain these 3 options that we skipped. Okay. So the first one is use cracked section in all vertical load combinations. This will be used when you are considering a cracked section. It means when you are considering seismic. Okay. So for our case, we are not considering the seismic, so we are not going to pick this. So we have the second one, general combination for steel members. You will check this if you want to create a load combination for steel members. It means in your model you have steel and you want to design, analyze and design steel. In that case, you have to create load combination for steel. Okay. Then the last one is about the notional load. It is under the horizontal load combinations, and we are not taking into account horizontal load combinations. Okay. So for our case, check the second one to generate load combination for steel because we are going to create a steel in a few minutes to come. Okay. The roofing will be steel. Remember, we will create trusses of purlins and cladding. So click this. Make sure in horizontal load combination nothing selected. Make sure in vertical load combination nothing selected except this, and click on OK. So if you click on OK, you will now have only one load combinations, which is actually this is the one we are using in manual calculation most of the time. Okay. Do you have all these load combination? So I just make sure that nothing is selected here, either on vertical and horizontal. Or if you have chosen to have multiple load combinations, it's okay. Good. Then click here, you will have this. And in Protastructure, we have differentiated different load combinations. You can see the ultimate limit set for RC and steel. Okay. You can also see the serviceability limit set for reinforced concrete and steel. Okay. Under this folder here. So that's it. Okay. Then click OK. So for my case, I'm having this pop-up telling me that before there was some load cases that I have removed, so they will be deleted. Yes, I accept. Except now the load combinations have been set. Hmm. Are we together, online people? Yes, yes. Okay, good. Okay, good. So we are done with the load combinations. Here we have another button for the wind and for the wind settings. We are not considering the wind, but just be aware that you can set the winds here. You have option to import wind load, okay? But we have also an option for the software to automatically calculate wind factors using the wind calculator. So we are not going deep inside this, but for information, know that it is available. So if you use the wind load calculator, you see I have a warning saying that I have first of all to check the wind code, but I will not go through that. Okay, but just for your information, make sure that they are available. So these topics we are skipping in this training, they are regarding the seismic and wind and whatever. They will be covered in the upcoming training, the advanced level. Okay. So for the upcoming training, we will no longer go back to the modeling and whatever. So those training will be only attended by people who have attended the intermediate level. So in that case, we'll be dealing with those huge topics, okay, talking about these seismic design, wind loads, talking about the mat and raft foundations, piles, those huge topics that were not covered in this training. So good. So let's move on. Now here we have a material. So we are going to set materials. So these materials are just the reinforced concrete strength and the tensile strength for the steel reinforcement that we'll be using. So to set this, you have this table here. These are just like a summary of what have been stated. So to edit this, you will have to go through edit material here below. Edit material. So if you click on edit material, now you have this dialog box. So we are going to edit the material to be used. So you can see we have different members, column, shear walls, concrete beam, and so on. Okay. So to modify, let's start with the column, the first one here. If I want to modify the material for the concrete for column, okay, or simply the compressive strength, then I will have to click on this number here, C30. For my case, I have C30. So if you click there, you will have other grades of concrete here. So it's up to you to choose which one you will be using. Okay. Okay. So let's say, let me choose 25, for instance. So if I click on OK, these are just the parameters of this C25. So if you click on the next one, these parameters will change. Okay. For any case, if you want to add your own, which is not listed here, you will have to use the add and then feed in each and every parameters here. Mechanical property, design property, you have to feed them. So you must know them. So for our case, we are using C25. Then click OK. Now you'll see here on the column, it will be changed to C25. So you can do the same for the remaining members, but we have options in case you want to use the same grade for all members. Just after selecting this, you have option here to apply to all members. So if I check this and click OK, now all the members will be changed to C25. So on the right side, we have the grade. Now we are talking about the reinforcement, the steel. So if you click on one of these, okay, now we also have rebar grades here. So again, you have to choose one of these. I'm choosing 500 and I will apply to all to make sure that they are applied to all material here. Good, are we together so far? So regarding this steel reinforcement, there is another crucial things to do, okay? Click on one of these to go back to the rebar grade. And under properties here, these properties here, steel parameter property, you will see rebar diameter. Okay, under rebar diameter, click on edit. Okay, go all the way down to rebar diameter and click on edit. So I will repeat it. Select one of the grades here. Okay, then go all the way down, you see rebar diameter and click on edit. So you have another table here. So this table is related just only to the diameter of reinforcement. So you have to choose which diameter you want to use for each and every member. Okay, the diameter, the size of diameter of the reinforcement, steel reinforcement. So if you check this first column here, this first column is about a column member. The next one is about a wall. Next one about the beam and so on. Okay. So let's set them together. So for instance, for the column, I can say, I can choose the diameter. Okay. I can say maybe I want to use a 14, 16, maybe. So it's up to you to choose, depending on what is available on your market. Okay. But of course, you have to remember that the minimum reinforcement in the column, according to the code we are using, is 12. So don't go below. So try to tick. Try to choose the reinforcement, okay? Take a minute and do that. For the column, for the beam, for the slab and footing, because those are the members that we only have. Even for the links, okay? So to take like 2 minutes and try to set the reinforcement. So remember that when we will be designing our members, the software will have to choose only among the selected diameters. So for instance, if for the column I have selected 14 and 16 only, so the software will only use 14 and 16 for the column. Okay. So, sorry. So are you done with selecting? Okay, so if you are done with selecting, okay, If you are done with selecting, then click on OK. Okay, so if you click on OK, then click on OK again. Remember to apply all to all members, then click on OK. So we have setted material for concrete, even for steel reinforcement for the superstructure. But if you check here on the left side, we have even the foundation floor. So the default materials are for the superstructure. So for the substructure, for the foundation floor, we have the foundation floor here. So if you click on it, again, you have parameters related to the footing. Okay. Again, you can add. So if you are done with these two, then click OK. Now we have changed the material. You can even see the summary here in this table here. Yes, we have also material for steel members, but we are not concerned with steel. That's why I didn't go through this. Okay, so if you are together so far, if you have set it, you are here. Okay. For now, please make sure you close this. Make sure you close, and then save. Okay. Make sure you are saving your project so that you can be sure that you have saved. Okay. So make sure. Good. So we are done with the first, the play analysis. Good. So the next one is the model option. Okay. So let's have a break, and after break we go on with this model option and explore everything here in the model option. Okay. Good. So we are having a break, and we'll be back after 30 minutes. Okay, good. So let me share the screen again so that we can go on with the next topic. Okay, so good. So we were on the settings of the building analysis. Okay, so we have covered so far the pre-analysis tab. These the settings within the pre-analysis. We have set the load combinations. Yeah. We have also edited all the material as required. Now we are moving to the model option. Okay, we are moving to the model option. So please everyone go to the model option. So on the model option, we be able to see different tabs. We have the model tab, the shear wall model, slab model, and settings. Okay. So we are going to see all these tabs together. Good. So let's start with the model tab. In model tab, the first parameter you receive is the material and section effective stiffness factors. This one. Yeah. So in case you will be needing to edit the stiffness factors, you pass through here. Okay. Again, this will be only used when you are dealing with a cracked section. It means when you are dealing with seismic. Okay. So we not edit these parameters, these stiffness factors, because we are not dealing with seismic. But for your information, if you click there, you'll be able to see different stiffness factors. Then you can edit them here. But we are not going through this because we are not dealing with the cracked section. Okay. So the next one is the general. These general parameters here we have here. Okay. So under this general, you see that the first settings, first parameter is the story degree of freedom. If you click on the drop down menu, you will see we have 4 different story degree of freedom. Okay, so we have X and Y, X, Y, and torsion permitted. First one you have, the second one X and Y permitted but torsion prevented. We have the third one which is only X permitted, and the fourth one which is only Y permitted. So this is just to set the degree of freedom of your building. So taking into account that we are modeling a 3D model, okay? Remember, you have a 3D model, right? As long as you are dealing with a 3D model, you will not need to use the two last option, okay? Only X permitted or only Y permitted, because this will be used only when we are analyzing a 2D frame, okay? And for our case, it is a 3D model that we have, so at any case, we will not need to use these two last when we are dealing with a 3D model like we have. Okay, so the remaining option is the X, the two first. Okay, so depending on the structure we are working on, depending on the form, the geometry, the surrounding of your building may tend to have torsion, okay? To have torsion up due to the loading, okay? So in that case, you will use the second option, X, Y permitted but torsion prevented. But if you have like let's say like a regular form, so you see the structure we have, it's almost like a rectangle, okay? So torsion are not likely to happen, so you can use the first one. Good. The first. Yeah. So the next one is the rigid zone. So when we are talking about the rigidity here, if you click on the drop down menu, we have around 4 options: maximum, reduced by 25, reduced by 30, 50, and none. So simply the rigidity zone we are talking here is the connection of column and beam, that joint. Okay, so normally because we are dealing with reinforced concrete, we have a rigid zone. Okay, it is rigid. So it means we don't have to use none. If you use none, it means you are saying that there is no rigidity, which is wrong. Okay. So for our case, the none option is not permitted, if I can say, because we are dealing with reinforced concrete member. The column and the beams are casted monolithically, so we have a rigid zone, so we must consider the rigid zone, the rigidity. So we remain with the 3 options. Maximum. If you choose maximum, it means you are considering that the rigidity is like 100% considered. However, when we are on construction site, there are some minor errors on construction site. So the rigidity between the beam and the column cannot be 100% correct. So it means if you use maximum, so it is not, you are considering that the rigidity on the side will be perfect. Okay. So which is not happening on site. So that's why the software have provided the 2 other options to reduce the rigidity, which is actually on site. So you can choose to reduce this rigidity by 25 or by 50%. It's up to you. Okay. Good. But for our case, because we have as a summary for our case, because we have a concrete structure, it means we have a rigid zone. Okay, we will not choose none, because we know that the construction site at the construction on site is not perfect 100%, so it is not ideal to choose maximum. Then we have to reduce the rigidity. So we are going to reduce it by 25. You can even use 50 if you wish to. But let's suppose that maybe you were dealing with let's say like steel members. Okay, you are designing like a warehouse where the column is a steel, the beam will be also steel. Between the column and the steel, the column and the beam for steel side, maybe you connect using the bolt and whatever. So there is no rigidity between the column and the beam. So in that case, maybe you can use none. Okay, so that's how I can explain this rigidity zone. So the next one is about ignore rigid zone in beam to beam. You remember I've told you that this first one was between column and beam. So how do you want to react how do you want it to react on a beam to beam? Well, because when we have like a primary beam, you have a secondary beam, you have a connection between beam and beam. So do you want to consider the settings that you have set for the rigid zone here, or you want to ignore? Okay, so I want to consider them, so I will not check this. Good. So the last settings about this general properties is the BIM section. Okay, how do you want to analyze your BIM section? Do you want to analyze them as flanged or as rectangle? Okay, so we'll go for flange, of course. Right? Yeah. So the next, which is the last on the model tab, it is the soil structure interaction. So we have two options. Okay. I recommend you, because most of you are beginners with the software. Whenever you see we have some explanatory notes, just try to read it to understand. Whenever you are doing like any action and you see a pop-up message, maybe a warning or a message, try to read and see what they are telling you. It will help you to more understand what is happening. Okay. So regarding the soil structure interaction, we have two options. We have user-defined support. We have also match foundation model. Okay. So as you know, we are going to do the analysis, and at the bottom of the columns here, where the superstructure will be connected to the foundation, there are some default support that we have assigned. Okay, the fixed support. You can see all the columns have these symbols. Okay, so these are the user defined, because it is we as users that we have decided to put fixed on all the columns. Okay, so remember, I have showed you how you can change the support. If you go to the column under settings, you remember we talked about the support. So we as users, we were able to define this support. That's why I will choose user-defined support here. So in this case, the model will be, the analysis will be considering the support that we have defined in the columns. Okay. So that's it about the model option. Okay, that's it about the model option. This, this is a model tab here. So take like 1 to 2 minutes to investigate the settings by your own on your computer before I go on with the next one. Okay, good. So let's move forward and go to the shear wall tab. Under the shear wall tab, we have two analysis options. We have a mid-pier model and the finite element shell model. So in our project, we don't have a shear wall. So if you choose the first or the second one, it will not affect our project because we don't have any shear wall. But simply, if what I can tell you about these two options, using this, you remember in the analysis, I told you that here, you remember under analysis, we have finite element analysis for the floor and for the foundation here. Okay. If you use this second option, it is the same. You are using finite element shell model, but for the shear wall. Okay, so you remember what we had here was only for the floor or the foundation. So for the shear wall, if you want to analyze using finite element, you will click this. Okay. Good. So you know that we are not covering the finite element, so I will not talk much about this. So let's move on to the slab model then. Go to the slab model and set settings related to slabs. Okay, for the slab, we have different settings, so let's see them together. The first one is the story diaphragm. So you have three options here, as you can see. So we are going to see all these settings, the meaning. So let's go on. So we have diaphragm. Okay, so maybe for you to understand this much better, take a diaphragm like an horizontal plane, if I can say. Okay, like a horizontal plane. So for the first option, okay, if you did, it is saying slab to define rigid diaphragm. Okay, what it means, because the software, when it is doing the analysis, okay, it is taking mainly for the slab, it is supposing that all the slab, okay, are lying on one diaphragm, like one plane, if I can say. Okay, so if you check the first option, slab to define rigid diaphragm, it means the continuity of the slab will define the diaphragm. For example, if I demonstrate it using this one, the model we have, because all the slabs here are connected to each other. So it's like we'll be having only one diaphragm because all slabs are connected. Okay, but if we have a scenario which was like I want to delete slab which doesn't have loads. Okay. So if we have a scenario which was like this, okay. So these slabs are connected here, but you have another slab connected here. So there is a gap in between. So in this case, we will have two diaphragms. So this will be one diaphragm. Because slabs are connected together, they are forming one diaphragm. We have a gap here, but the remaining slab here at the top, they are forming another diaphragm, another plane, if I can say. Okay, so I will do the Ctrl-Z to bring back my slab. Because we don't have gaps between slabs, so it means we will have one diaphragm. Okay. So that was for the first option here. So for the second option, single diaphragm per flow level. So it means instead of considering connected slab to form a diaphragm, we will take diaphragm as a flow. It means one flow is one diaphragm, another flow is another diaphragm, and so on. You see the difference, right? Am I explaining it fairly? Because I see maybe you are not understanding. For the first option, the slabs, the continuity, the connection of slab will define diaphragm. Okay. For the second option, the diaphragm will be defined by flow, by stories. So the one story will be a diaphragm itself, another story will be a diaphragm without taking into account the continuity of slab. Step to what?
Yeah, not only staircase. For instance, I have the same floor. We go to the step. It may be dining or whatever I decided to drop it.
Okay, so I got you. So if you have that scenario, okay, here in the room, they were asking if you have like it's like you have an intermediate level. Okay, so slab are not on the same level. Okay, so in that case, if you choose the first option, okay, because those slab are like they are acting that like they are not connected. Okay, so it will be two diaphragms which are separate. Okay, but when you choose the second option, we don't need to go further on those concern of continuity of slab. Just the flow will be considered as one diaphragm.
You have the construction.
If you have like expansion joint, okay, so if you use the second option, you will have one diaphragm. But if you use the first option, because there is no continuity between slab, then we have two diaphragms. Okay, good. I think now it is understandable. So we have the last option here. No rigid diaphragm per floor level. So it means in this case, okay, in this case, the last one, we don't need to take into account, the analysis will not take into account those diaphragm we're talking, okay? So I will just like give you like a practical example so that you understand what we are saying. So you remember I told you these diaphragms are like planes, and the software is always considering that the slab is lying that plane. Okay. So let's suppose you have chosen this second option, single diaphragm per floor. So it means first story will be one floor, one diaphragm, okay? Story 2 here will be another diaphragm, okay? But remember, we have this inclined slab, okay? You have specified that diaphragm will be defined according to the story levels, the floor. And yet, in your first story, we have inclined slab. And this inclined slab is not lying in the floor, in the diaphragm. So it means when you analyze, you may have error. Because you have chosen to define diaphragm by story, and you have one slab which is not in that diaphragm. So you may find an error. Okay. So in case you have this scenario, what you have to do, you have to go to the settings of the slab. If you open the slab property, the slab property, okay? And if you go to the loading, you will see an icon, an option here, which says slab does not contribute to the floor diaphragm. So you must make sure that this one is checked. Okay? So in that case, when the software will be doing the analysis and whatever, it will see that you have said that this slab is not contributing to the diaphragm that you have specified. So the same scenario goes when you are dealing with, let me go back, when you are dealing with this first option, okay? Again, you have to make sure that under the slab property, you have checked to the slab to not contribute to the flow diaphragm. However, if you have checked the last option here, no rigid diaphragm per flow level, okay. So in that case, even though the slab under slab property, this is not checked, it will not cause any issue because we have said not to consider those flow diaphragm. So simply, in short, that's the meaning of this kind of thing. Okay. So for our scenario, let's go with no rigid diaphragm per flow level instead of going to this or slanted slab and modify. Okay, so let's go with this. Then the next one is finite element mesh. Okay, so in that case, you want to mesh your slab. Okay. Simply, this is finite element analysis also. Meshing. If you check this first option, now the below settings will be activated so that you can put values and whatever. But if you uncheck, everything will be grayed out. Okay. So we are not going to mesh our slab. Just leave it because simply you will need to use this mesh. Okay. If you have conducted the flow analysis, a finite element analysis. Okay. If you have conducted the finite element analysis here, then in building analysis, you may want to mesh the flow. But because we will not go under the finite element, so make sure that this is not activated, so we will not mesh our slabs. Okay. So the last option is this setting here, settings tab. Settings tab, just you can read and they understand what they are saying. It's, for instance, if I explain, let's say for this first option, it is saying issue warning for cantilever beams not marked. You remember I have insisted that all cantilever beams must be marked. You remember the red triangle. Okay, so you see this triangle here. Let me remove the. You remember the cantilever have to have this. Okay, so all cantilever slab must have that. That's a must. Now here in the analysis, if you take this first option, you mean when the software will be running the analysis and find that there is a cantilever slab that you didn't mark as a cantilever, do you want to have a warning? Before proceeding with the analysis, the software will warn you. A beam number labeled this must be a cantilever. It may be a cantilever and you forgot to mark it as a cantilever. So if you want to see those kind of warnings before during the analysis, you will have this. Okay? You have to tick this, and so on. You can even issue the others. Issue warnings for unsupported column before analysis. If there is a column maybe you have a column, or let's say you have a scenario. Let's say, let me try to create that scenario. You have something like this. You see in a 3D view how it is looking like. You have something like a column which doesn't have a support. It is like suspended. Okay, it is an unsupported column. This is an unsupported column. It is standing in the air. Okay, so if you are running the analysis and the software finds out that there is some column which is unsupported, do you want to receive a warning to be one? Then you have to choose yes or no, depending on what you want to achieve. So I will delete this. Go back to the analysis and the settings. Okay. So the next one is print member section in the pre-analysis report. So under the pre-analysis report, do you want to see the section of members? If yes, you tick it. If you don't want to use it, you uncheck. So create detailed analysis echo file. These by default you have to leave it. It will just create additional file which I don't think is necessary. Then the last one, use space server for building analysis. Okay. So using the space server, you can leave it because our model is simple, if I can say. But for those who will attend the upcoming training, we'll talk much more about the space server, because sometimes you have to uncheck it when you are dealing with those huge projects. Okay, it's all about the calculating time of the software. Okay, so then here we have the total and relative horizontal drift. Okay, maybe I will demonstrate it when we will be reaching the reporting. Okay, so there are some drift which are these values are defaults. You can change them, but they leave it to the default. So there are some horizontal drifts that a structure may undergo because of the loading and whatever. So we have the minimum and the maximum. They are acceptable. Okay, so these are acceptable ones. So if the drifts go beyond these values, you will have a warning. These are ratio. So you take the horizontal side, you divide the vertical, have ratios. No, it should not be 0. Those values are exact. They are known. Okay. So we have actual load comparison, tolerance. This will deal with how the load have been distributed from the top floor all the way to the ground floor, to the foundation. So when you are decomposing load, maybe from slab going to the beam, then they will come from beam to column all the way down. Okay. Actually, the sum of all the loads, live load and dead load, before decomposing the loads, may be equal to the sum of the load after decomposition. Okay, because if you are saying that load which were on slab have been transferred to the beam, it means the beam have the total load on the beam itself after decomposition must be equal to the beam plus the slab before decomposition. So the allowable difference is 5%. Okay, so it means if the difference goes beyond, then we also have a notification. So that's the meaning of this. Then lastly, we have to say if we are using decomposed beam load or uncomposed slab load. So because we have beams, okay, we will use decomposed beam load because load will be transferred from slab to beam. Okay, but if you are dealing maybe with like flat slab, you don't have beam. In that case you use uncomposed slab. So for our case, we have beams, then move it to decomposed beam load. Okay, so you can take a look like on this information here. That's why I was telling you just to regularly lead. It is saying in a particular story, if there are slabs that are not transferring their load to the beam, story weight and center of gravity must be calculated based on uncomposed slab load. Okay, so that's what I have explained here. So that's it about the settings, the mode option. Then the next tab is the slab analysis. The analysis. So before going to the analysis, close and save to make sure that the settings that we have set are saved. Okay. Then go to the building analysis again. I'm telling you to close and save, okay, to make sure that what we are doing are being saved, but it is not mandatory to save each time you leave any tab, okay? So the last option for the analysis, going to the analysis, so it is this analysis tab. Please move to the analysis tab. And the first option you see is the building model check. You remember the model check that we did previously? So here we have it again. You can again double check to make sure that you don't have those obvious errors. Okay. Before going to the analysis. If you don't have those errors, then click on building analysis. Yeah. Building analysis. If you click on building analysis, you will see this table, the batch design option. Okay, so if you have this, okay, please don't tick anything. Make sure that everything is deselected. Nothing is selected here. Do the analysis, the building analysis. Building analysis. Good. Make sure nothing is selected. Why? If you check, for instance, this column wall reinforcement design, this is a design, okay? It means the software, after running the analysis, it will automatically do the design. So we don't want to do that, okay? Never do that unless you are sure that your analysis is okay. So it means you have first of all to run the analysis, see how the forces, the loads are affecting your structure. If there is something to correct, go back to the model, correct run the analysis again. If you are okay that the analysis is okay, then that's when you can go to the design. So make sure that nothing is selected, just run the building analysis. So it will calculate. So depending on the size of the project, depending on the capacity of your computer, it will take different time. But at the end, you will see here below, analysis completed, and you'll see a green arrow here, a tick. Okay. So if you don't have a analysis completed, then let me know so that we can see the problem. Okay. So if it is completed, if you close even this tab, you will see under the building analysis, we have also a green tick here. You can save, it's okay. You can save. Okay, Engineer Romeo, analysis successful, good. Waiting for the other participant online. How about you? A and B, good. Mariana completed, good. Yes, A and B, you are supposed to leave all boxes unchecked, yes. Because, let me bring it back. So if you do the analysis, okay, and leave everything unchecked, okay? Because if you check one of these, it means after the software run the analysis, it will automatically do the design. And you know, as it is our first time doing the analysis, you may think that there is some errors in the analysis. And if you have checked to design automatically, you understand that your design also will be wrong because the analysis was also wrong. So it's better you leave everything unchecked, do the building analysis. If you find that everything was okay, then move to the design method. Yeah, good. That the analysis is successful, good. How about Chedi? Great. So give me like a few minutes to check here in the room if everything is also okay, if the analysis are successful for physical people here. I will be back. Okay, good. So now, if your analysis is okay now here, if you go to the review tab, remember the review tab, and turn on the design status, you see that still everything is not designed. Okay. The minimum must be 5%. Okay, so you see that nothing was designed, okay? Which is what we wanted, because what we have done is just the analysis, not the design. Okay, we have only run the analysis, not the design. And the purpose of analyzing a structure is just to do what? To see how the loads are affecting each member. So from there now, we will be designing to know which section, which reinforcement, must support the load from the analysis. Okay, so I will again deactivate this. Now let's go and analyze our structure in an analytical model. So how to open an analytical model? We have two ways. Under analysis again, you remember where under the building analysis, after the analysis tab that we went through, we have a post-analysis. Post-analysis. In post-analysis, you will see analysis results. It means these two buttons deals with the analysis result. You can display analytical model, or you can view the analysis report. Okay. The next one is about the design. You can design column, walls, and you can design beam. Okay. It is all under the post-analysis. So we are not yet to the design. We want to see only the analysis result, the result from the analysis. Then open the display analytical model. If you click on display analytical model, it will load, then it will open something like this. So it is like, it is no longer a 3D model, it is the analytical model. Okay. So I will close this to show you another way of opening this. Instead of going through this analysis, whatever, still under analysis tab, you will see analytical model. Again, if you click on it, it will open the analytical model. Okay. Yes, you will see all the way to the right, you will see analytical model. So let's look together with what we have. So you will see that we have analytical model heading here at the top. Okay. Please take a look here. As long as it is analytical model, it's okay. If it is different from mine, it is because of the settings we are going to see in a few minutes. Just make sure you have your wireframe model. And you will see that you have analytical model heading here at the top in a blue color. So if you check well, this analytical model comes with 5 tabs. You have general tab, member tab, result tab, contour tab, and solid model. Okay. Are we together all? 9 people confirm that we were able to open this analytical model, and we are able to see these 5 tabs: general, member, result, contour, and solid. Good. Okay. So the purpose of this analytical model is to investigate our model and see how Mariana, you are asking me to repeat what? Please clarify. Mariana, what do you need to repeat? Okay. So Let's go on and then investigate our model, right? So I was saying that we have different tabs, okay? The general tabs have different settings. I would give you time you will have time to explore each and every things we are seeing here. Me, I'm going just to talk about the main points. So you will have to explore the remaining ones at your own. So under the general, I'm starting with the general. You can see we can view the plan view of our structure, or you can view the 3D view, okay? Using these two icons here. You can view the 3D view, okay? Or you can view the plan view, okay? That's the main important things here. Then we have a filter command here. We have a filter command. Make sure it is highlighted, it is turned on. So the filter command actually is this one. You see this one here. So if I click on this, it will be hidden. If I click on it again, it will appear. So make sure your filter command is active. If you are able to see the 3D view and the filter command is active, that now move to the member side, to the member tab. The 3D view, no, make sure it is active here. Is it active? Do you have something like this? Do you have something like this? Can you deactivate the plan view? Only remain with the 3D view? Do you have that? Do you have something like this? So can you rotate? Just rotate to make it free. Okay, good. So when you were in plan view, after you deactivate, still act like this plan view, but it is a 3D view because there is a box here. So it's a matter of rotating. Now go to the member tab. Under member tab, we have different parameters that you can turn on or off. For instance, if I give you like an example, you can see these red dots. These are nodes. They are visible because nodes here are activated. So if I deactivate, they will disappear. See? If I activate it again, they will be activated. If I try to turn on the label of each node, then they will be labeled. Or remove the label, and so on. So these are all the parameters of the nodes. Okay. You can use these parameters here to turn on the frame. See, frames are turned off now. If I click on it again, they will be turned on, and so on. All these settings are related to the member. Okay? You will have to explore them one by one later. So the more important things that I want you to see here is this, the flame load. Click on flame load. If you click on flame load, you will have these loads on BIM like this. Okay. So now these are the loads after decomposition. Okay. Remember, loads from the slab have been decomposed to the beams. So now if you check well, we no longer have slab in the middle. We have only loads on the beams. So if you have a lot of information in your model, like I have here, you can use the filter command I showed you here on the left side to decide what you want to view or what you want to hide. For instance, I can say I don't want to see. You can filter by story, by axis, or by member type. You can say I want I don't want to see all the view, I mean all the story. I only want to see the story one only. So if I activate story one only story one will be activated. So I will be able to view my model more clearly. Okay, so you can say I don't want to see all the axis, I only want to see axis 1. So in that case, you will have only axis 1 activated using this filter command. You can say I want to see all the axes, for instance, but I want to see only beams. Now only beams will be visible. So it's up to you depending on what you want to achieve. And let's say if I take an example for this, you can turn on the frame load, okay, the label now, because these are in a form of figures only. But if you turn on the label, now you will be able to see exactly how much kilonewton per meter are being inserted on the beam. You will be able to see the value, the exact value. Okay. So that's how you can do this. So in any case, let's say, for instance, okay, let's say, for instance, I know that this is one of the beam, okay, supporting a rectangular load. And if I would have seen a triangular load here, okay, I would have automatically know that there is something wrong with the model. So I have to go back in the model, correct it, then run the analysis again. Okay. So if that's how you can investigate this. So make sure that you turn off the load frame. Okay. So we are going now to the next one, which is the result. So under member, the load we were seeing, those are the loads that we have applied. Now we are going to see the results. So move to the result tab by making sure that under the members, these two are deactivated. Okay. So frame loads are these shapes, these geometric shape. Then labels are the values here. Okay. Now go to the results. Under result, the first thing we are going to check is the displacement. Okay. We have displacement here. So click on displacement. You will see the red lines showing you the displacement or the deflection. Okay. So I will try to open only one, let's say like one axis so that you can see the deflections. Okay. Good. In red color. Can turn on all the axes to see how it is behaving, deflections. And regarding the deflections, if you check well here at the bottom, you will be able to see the maximum and the minimum deflection that we have. Okay. And if you click on it, okay, it will automatically show you where on your model those values are located, the maximum, the minimum. And you will see that on the right side. Here on the right side, you have load combinations, load cases and load combinations, the ones we created, okay? And you'll be able to see the envelope. So by selecting one of these, okay, the deflection will change, okay? Not only this act on deflection, but if I deactivate this and go back to members where we had loads, okay, you can see if you want to see the effect of the dead load only, the effect of the live loads, these are live loads, or the combinations, okay, under the load combinations. So it means the combination of dead load and live load. Or you can change dead loads, now live loads. Good. So turn off the displacement, okay, turn it off and open the diagram. We have diagram here now. Diagram under results. So now the diagram, okay, will be turned on. Good. Again, you can change between different load cases or load combinations here to view the different option here. So regarding the diagram, for my case, I'm only able to see diagrams on the beams, okay, because it is beam which is activated. I can deactivate beam and activate maybe column, okay. If I activate column, now I will be able to see all the loads reaching the column, okay. Just by seeing this picture, I can automatically know the column which is having maximum loading, okay, just by viewing the figure. I know that the columns around here, this doesn't have much actual loads because it is around 100 and something, but this one here, it is around 300, okay, so I can exactly know that we have this column is supporting much load rather than the one which is located around somewhere, okay. So this will help you even, it is very important to view all these results because it will help you to understand which member is much loaded, which one is less loaded, okay. You will have a picture of your framing structure even before you go for the design. Okay, I can view the upper story, for instance. Good. You can even change the type of loading from actual load to, and you check maybe, let's say shear. Okay. You can check shear if you wish. Can check moments. Let's check it for the beams, for instance. Can check the moment for beams. The maximum is 32 for this beam, and so on. So you can check any kind of result you want here. Good. So I will turn off diagram again. Make sure our story are selected. Good. Now the next tab is the contour. So we'll not deal with contours because these contours will help us when we have run the finite flow analysis. So we didn't, so we not cover this. Even the solid model will not. But for the solid model, it is almost like what we had in result. The only difference is that your model will have a legend. Okay, we will have color showing you the most and the light loaded members. Okay, so again, you can see through the legend that. Let me maybe turn only the story one. Okay. You see that among the columns, this one will be the more loaded according to the color code. You can see the most loaded around 300. It is this one in my model. Okay, good. So after viewing the result of the analysis, if you find that there is nothing suspicious, everything is okay, then close the building, the analytical model. And now you are ready to go for the design. If you find that there is something wrong, you have to come back to the model and correct it, then run again the analysis. So that's why I told you it is not a wise decision to when you are doing analysis to directly tick this, because sometimes you may find that there is some errors that you need to correct before going for the design. So I will save my project so far. So is there any question? Yes, so let me come. Online people, if you have any question, just feel free to write it in the chat box. So and B, you're saying you have sent a message in WhatsApp. So the message is about the actual load comparison one. So simply, you remember when we were talking about the settings you have to set here under settings, the actual load comparison. The percentage that we set was 5.5. I mean 5%. And for you in your I can see you have 5.5 after the analysis. It means the difference in loading have exceeded the 5 that we set. So that's why you get that warning. Okay. So to check this very well, if you go back to the analysis, you will see actual load comparison report. Okay. So if you click on this actual load comparison report, you will see these tables. Okay. You see these tables. It means these here are the load before we compose the load from the slab to the beam. These two first table. This is for the dead load, and this is for the live load. Okay. Then the second one, these two tables are the table of the load after we decompose the load from the slab to the beam. So if you check well here, on the slab we had values here, but after decomposing, it became 0. It means the load from the slab have been sent to the beam. Now the load from the beam have been increased. Okay, so actually, it means the values here, the total here must be equal to this, and this value must be equal to this. Okay, so the allowable difference between these two values is the one we set here. The difference allowable was 5%, but you have 5.5. Okay, so this value range from 5 to 10. Okay, so this is just a warning. It is not an error. It is just a warning because you have set this setting. So that's how it is. I think I've answered your question. So if there is any other question, then let me know for the online people. If there is no question, we are remaining with around 40 minutes before the break. So what I need you to do, okay, take a look here. So we have done the analysis. We have this green tick here. So it means we are ready to go for the design, okay? But however you do any change to your model, okay, if you do any change, let's suppose I have this wall load that I have placed here as a parapet wall. This I have placed here as to act as a parapet wall. If I select it and try and delete the load, okay, I want to delete the load, I will automatically see the warning. Okay, it means if I do this action, the analysis that I have done will be invalid. Okay, because I have done a modification, I have removed some loads. So it means the analysis automatically will expire. Do you want to continue? So if I click on yes, you see the load have been deleted, the wall here, but you see automatically there is a cross arrow on the building analysis. It means the analysis is no longer valid. If I even turn on the design status, so it will not be visible because we didn't do the design yet. But you can check it through the analysis. You see that the building analysis here, you have a cross arrow. Even though if I go to the building analysis here, you see you have a cross. So it means any change you do to your structure, to your model, you have to reanalyze, to perform the analysis again. Okay. Even though I do undo to bring back the word that I have deleted, I have to repeat the analysis. Okay, so that's very important. So if you click on analysis, the settings that you have set it, they are still there. You can just simply go to the analysis and run analysis. Okay. So what I want you to do in the remaining minutes. Now, for now, we see we have two story. I want you to create another story. Okay. So I will do it quickly. So take a look so that you do the same on your side. I will insert another story to make them 3. Okay, like this. And then I will go to the story 2, the plan of story 2. So I want to, what I want to achieve simply, I want to bring this, to have access to the rooftop here. Okay. So what I will do, I will take these columns. I can even take beams if I wish. So we are going to generate only this at the top of the stair, where we had the stair. Okay. Selecting this. Then I will generate only these members Remember that the method we saw was by going to generate member was by passing through story here. But if you select some members, right click, you will again see generate member to other story. So in this case, the member which will be generated are only the one you selected. Okay, so I will generate them to story 3. Click OK. Then I will have something like this. Okay, so you are going to do this, elevate this and this. Then at the top of these beams, okay, you are going to put trusses, okay, purlins and cladding. It means we are going to have the top here as a roofing. Okay, so that's what I want you to do. Okay, you have already modeled the story 1 and story 2. Add the story 3. Elevate the columns and the beams for which is along the stair. Then at the top here, model the roof member, truss purlins and put cladding. After doing that, now we will analyze again. Then after break, we'll start the design. Okay. So go on, please, and do the same. After putting these plank levels, okay, please go back and do the analysis. Okay, under the building analysis, then run the analysis. Okay, again to make sure that you have a green tick like this. So when we come back, we'll be having our model, our complete model. We'll be having our active, up-to-date building analysis. Now we jump directly to the design. Good. So please confirm that everything is understandable. You are with us. Then we will go for the break. Okay. Please confirm 9 people before we move. Go for the break. Only Romeo is around. Okay, Mariana. Good, Daddy. So, Chedi, how about you?
Hey, engineers, as I just wrote in the chat box, at the physical venue, there's an electricity issue. So the instructor wants me to pass the message to you to keep working on the project, making sure all the roads are well placed, and doing the analysis, reviewing everything that we passed through, and then he's going to join the later on. So stay here, don't go far from your PC online. He's going to, he just joined us. I can see him. Thank you.
So have you all, for the online people, are you done with modeling the element on story 3? And have you all have run the analysis, the building analysis? You have this green tick arrow here. Okay, good. So now let's go with the design. So we are done with the analysis part, analysis tab here. Let's go to the design tab. We are now moving to the design tab. So you can see that the remaining tabs are few. So we are nearing the end of the training. Okay. So please, everyone move to the design tab. So we are going to start designing. We have the column design. So simply we have reinforced concrete. Okay, these tools are to design reinforced concrete members here on the left. On the right side, we have a panel containing tools to design the steel members. It's like it is arranged the way it was arranged in the modeling tab. You remember in the modeling tab, we have reinforced concrete members tools, the left, and for steels on the right side. So it's the same for the design tab. So let's go on. We are starting with the column. So click on column design, and we have this table here. I will try to expand this so that I see. So simply under the design status, you will see that all columns have this cross. Okay, it is because they are not designed yet. So on this table, I have a list of all the columns. Okay, I have in my model. You can see I have the column name. These are the names of the columns. We have story. Okay. We have the cross section P1 and P2, and now we have the design status. So it is not active so far. So to perform a column design, we have two options here. We have the first one, which is the interactive design. We have the second one, which is the batch mode design. So we are starting with the first one. So to design a column, simply select the column you want to design, the list. I have selected the first one here, and click on interactive design. Click on the column you want to design, then click on interactive design. If you click there, you will have this table. Good. Or simply, when you are on the list here, if you double click the column, again it will open the interactive design. It acts as an interactive design. It will open the column design. Okay, so if everyone have this column design tab. So what you are going to do, okay, we are going to click on interactive design, this one at the top. So if you click on this interactive design, the software will do some calculations, okay, and it will give you this summary. In this summary, you will be able to see the loading on the column, okay. These are just design settings. In the bottom, you will be able to see the reinforcement provided. For my case, it is 4 rebar with 14 diameter. Then if you click on OK, and click on OK again, you will see that my column have been designed. Now the design status is passed. Yeah. And if you check well on the remaining columns here, I have information there. Okay. I have supplied steel. I'll have the steel rebars here. I have also the links. They have been filled. Okay. So I repeat again using the second column. Second column here. I will select it. Interactive design. It will open this dialog box. Okay. Without changing anything here, then I will click on interactive design. It will automatically design, give me all the summaries. I can see even the reinforcement here. If I click on OK, OK again, it will be passed. So try this before I go and explain all the settings within the column design. Sorry? To design multiple columns at once? Yes, you can do that. I'm going to show you how. Okay, you can do that also. So the way by default columns are arranged, you see, we have they are arranged by column themselves. This means I have one C1 and two C1. So I have first of all one column. Okay, it means this one and this one, it is all column 1. Okay, then the following 2 is another column, okay, and so on. But if you want to arrange them, to sort them by story, you have to come here on story. If you click here, then you will first of all have all the column on story 1. You can see all of these are story 1. Then we have story 2, then story 3 at the top. So it depends on how you want to sort them, if it is either by column or by story. Good. So have you designed? So someone asked how to do a design of all columns at once instead of using interactive design. Now I will use the batch design. See the batch? Yeah. We have a batch design. You don't need to select all, just click on batch design. Yeah. This column design batch mode. Okay. If you click there, you see this dialog box. In this dialog box, we have three options that we are going to explain. We have three options. The first one, starting with the first one, select new still when the previous bar are insufficient. Okay. So suppose that you have previously done a design, and now you are redesigning for the second time. So if you choose this first option, the software will do the design. Okay. If there is some member which has insufficient reinforcement, then the software will update it automatically and put the required reinforcement, the needed one. If you choose the second option, then the software will do the design again. If there is a member which is insufficient, which is failing, the software will not update it automatically. It will just mark it as failed, but it will not update the reinforcement. Okay. So the last one, reselect all rebars. It means ignore the previous design that I have did, then conduct a new one, put all the new reinforcement. Okay. So that's what we are selecting. We select all rebars, then click on calculate. If you click on calculate, the software will perform the design for the columns. Okay, until you see this message saying process completed. Okay. Then if you click on close, you will see that your columns have been designed. All the columns. Sorry? Okay, so the message box, when you select all, let me repeat it so that everyone can see that. Yeah. After the process is completed, we have a message box. If you click there, then we will have the summary in a notepad form of all the columns. Okay, you can see column 1 on story 1, which was rectangular. The critical load combination used was 2 for my case, and the reinforcements provided. It's just like a summary of the result of the design. Yes. So you will see that all your columns now have been designed. What if? Okay, so we are going to see how you can correct those. We are going to see all these settings here in the design of the column. Okay, so let's go on and investigate these properties of designing a column, because every time you do a batch design, it's not mandatory that all your column will pass. So you have to understand how to deal with these settings here to be able to successfully design a column. So what I did, yes, I selected one column, then selected design to open this box. So we are going to see this the meaning of all these settings here that we have. So I'm starting with this portion here. It contains information for the cross section of the column. You see B1, B2, and B3 here. Cross section of the column. We'll see E, which is eccentricity. Then we'll see the L for the effective length of the column. Then lastly, we have the curve. So those are information regarding the column. So the message you are having, you may have not a valid building analysis. Can you repeat the building analysis? Repeat the building analysis. Run the building analysis again. Is it active? So please make sure that you are designing having the active analysis. Okay. So if you try to design without having an active building analysis, you will get some messages telling you that the analysis is not up to date. So make sure you run the analysis first. So now people, I'm supporting someone here. I'll be back. So is there a question online? Economic is very low. Okay, so we come back to your question in a few minutes. Engineer A and B. Okay. So take a look here. So we have seen that these are just dimensions of the column. Okay. Now here below you have a diagram showing you a cross section of the column, of course. Then here below on the right side, for my case, I have only one load combinations. One load combination. But if you have a lot of, if you have used the many load combinations, you remember when we created load combinations, they will be all available here. So the one which will be in red color, it means it is the critical one. Okay, the one being used in the design. So for my case, I only have one. If you check here, okay, we have information about the steel reinforcement. The provided one, the minimum, and the supply. You already know the difference between these area. Difference between area required, the minimum area, and the supplied area. So the information regarding the area, those areas are found here. And lastly here, you have a table, very important, of controlling the reinforcement in your column. For instance, when I did the interactive design, you see I have four main reinforcements. So they are controlled here. You can see in corner, I have one number. The quantity is one in each corner. It means I have one reinforcement in each corner. Okay. And then here we have the diameter. The diameter automatically was 14. But if I click on this, I will have a drop down. I can change even to 16. You see how they have been increased. Yes. So the diameter which will be visible here is the one that you have chosen. Okay. Remember when we settled the diameter of reinforcement. So if you change the diameter here, of course, the area supplied will change. Okay. So it's like you are designing manually. You are doing some changes. So now if before it was 40 bars of 14, I have changed to 16. If I click on OK, we see that here in the table, they have been updated to diameter of 16 instead of 14. Okay. So if I go back, let me bring this back to 14. I can even add intermediate reinforcement. For instance, I can add two other reinforcement here using this table here, intermediate rebar. I can even decide the diameter of those reinforcements. So now I have 6 reinforcements of 14 diameter. So if I click on OK, now here you see it have been updated to 6. You have 4 in the corner and 2 intermediate reinforcement. Yeah, that's the design actually we are doing. Okay, so it means what we are doing here, we are designing. Okay. I can even add other intermediate reinforcement in the direction 2 here. So you see, simply by using this table, you can increase or reduce the number and the diameter of reinforcement. Good. So here is a very important thing that you have to know. Okay. Here there is a very important thing you have to know. If you see, for now I have like 8 reinforcement. Okay. So if I click on OK, and you see under design status, I still have a green tick. Okay. So the column is okay, it's passing. The design is okay, but I can say it is an over design. Okay, because I'm providing 8 reinforcement where even 4 reinforcement can work. Okay, so don't say that as long as you are seeing a green tick here, it means you are done with the design. So you have to make sure that your design is optimum design. Okay. So that's okay, because you the software is just a calculator, so it is helping you to just do calculation very, very quickly. But at the end of the day, you as an engineer, you are the one to know. You are the one to put the judgment and know which conclusion I should take. Because, for instance, this will bring me to the question that our engineer A&B asked here online. Okay, he asked, column utilization ratio is very low. How can I optimize that? So it means when you double check here in this column, you will see a column for utilization ratio. Okay. So if I take an example for my column here, you see I have 0.03, okay, which is very, very, very low. Just by seeing this utilization ratio, I know that I have done a Nova design. Okay, I automatically know that I have done a Nova design, because you know utilization ratio, okay, vary from 1 to decimal numbers. Okay, so this simply utilization ratio is the ratio of the area required, okay, versus the supply, the area supplied. So if the number here is very low, it means I have provided more reinforcement than needed. That's the meaning. Okay, the reinforcement that I have provided are more than needed. So if I go back here, see it was around 0.03, and bring this back to the way it was before. It was 4. Okay, if I click on OK, you see the value here have increased. Okay, Sorry. So it will depend, but it must always be less than 1. Less than 1, because if it reaches 1, it means your column now is failing. So it means you are providing reinforcement which are raw than required. Okay? So if you have like 0. Let's say 9, from 0.7 to 0.9, you know that you are in a good range. So if the utilization ratio is very low, so it means you have provided more reinforcement, or your cross-section is very big. You can reduce the reinforcement or you can reduce the cross-section. Okay. So too many columns are not designed after. So Mariana, please, when you are doing a batch design, select the third option, which is the select all. So it means make sure the select all bars are checked, are the one checked, then do the calculate, it will be performed. So let me come back. So we have other tabs here. Okay, we have other tabs as well in the columns. We have links. Okay. The link tab, you can use this link button to have this type of different type of links. Okay. So I will explain this through the settings when we will be talking about the settings of the column, but simply it is how you can arrange your links in a column. You see, we have different arrangement, so you can choose what you want to use. We have a share design. When you go to share design, you will be able to see the value. I mean the share design here, the value, okay, for share. And you will be able to see the links provided, because you know those links we provide are against shear, is to fight against shear. So after the software calculating the shear forces, it will provide the shear reinforcement, which is linked. Okay, so you can see for my case, it have provided a reinforcement of 10 at a spacing of 150. Okay, and they are in gray color. I cannot edit this because they are the result from the design carried by the software. If for any reason you want to modify maybe the diameter of the links or the spacing, you have to click on this edited. If you click on this, then they will be activated, so you can change it manually. So, however, know that whenever you are changing this, okay, it's up to you. You know what you are doing. So, for example, if the calculated one, the spacing is 150, and I put 200, I'm messing up everything. However, I can reduce this spacing, but I cannot increase, because you know, as long as you increase the spacing, you are reducing the strength. Okay. Then we have the slenderness. Under slenderness, you will see how your column were designed. The bracing. Okay, so it was designed as a braced column. You will also see the effective length factor calculated by the software. Okay. They are all present here after the design. Then lastly, under the settings, just you can see by default there is no text. If I put to the next one, you see the label, the reinforcement are labeled here. if I click on the rebar diameter now, the reinforcement are rebared according to the diameter. So for instance, if I choose to be 16, now here it will be changed to 16. Okay. So that's it. If you want to label the column edges, you can do that. But personally, I don't prefer this. Okay. So these are the main settings here for the column. So before I go on, is there any other question? Physical people here? So, Mariana, can see your question here. So if you are having that pop-up of grading analysis, so it means that your grading analysis is not active. Make sure that it is sticked. So to make sure that everything goes okay, repeat the grading analysis. I have mentioned that after doing the analysis, whenever change you will do, your analysis will be expired. So you have to redo the analysis. Okay, so try that. So if a question of A, B, if we need to reduce column cross-section, we have to redesign in model and then to run analysis. Yes, that's how we can do. You can do both. If you decide to do let me show you. If you decide to change the section here, you will change it here. Make sure you update. Okay, but after updating, again you will have to come back to the analysis again and redesign again. Okay, so whenever you change a section, you already have to repeat the analysis. Good. So okay, you are welcome. A and B. Online there is no other question so far, so let me support the physical participant as well. Okay, so for online people, so I think on your end everything is okay with the column. I was disconnected a bit, so if there is a recent question you typed in the chat box, please resend it so that I can be able to see it. If there isn't any question, now we'll move on to the design of the next member. Okay, none. Okay, good. So let's go on. We are done with the column. So for now, if I try to turn again the review on the design status, you remember, if I turn my design status, all columns are okay, you see, but the remaining member are still white, which means they are not designed. Good. So I will turn it off again. So before we leave the column, I want you to show you how to create a report. Very important. Okay. So when we are still after designing everything here, take a look here. Some of the tips I want to show you. Sometimes you may want to. We have option to copy reinforcement from one column and paste it to the other column. So for instance, you see by default I have 4 reinforcement of 14 rebar here. So if I decide to put 6 reinforcement, click OK. Now here, only these have 6. I can just select this. And here I have a copy bars. So I can copy. If I click on copy, you will see equal sign in front of the remaining columns. This equal sign will go in the front of column which is similar to the one which was where I have copied the enforcement. It means the cross section are equal and every other parameter. So if I click on paste to all, now you see now all the columns have 6 reinforcements. Okay. So in a case you want to copy reinforcement from one column to other, it is still possible. Okay. Yeah, so if you copy and paste, okay, and the reinforcement you are pasting are not sufficient, then automatically the column will be marked as failed. Okay. So I will leave them to be 4. Another interesting thing when we are doing a batch design, I mean interactive design of a column, okay? You can view the elevation drawings. Okay, so if I click on elevation drawing here, so before going to the elevation drawing, start with the column analysis. So if you click on column analysis, we'll be able to see interaction diagrams for the column. Okay. You can change, you can toggle between different diagrams or show both. You can open the column diagram to view some forces. Okay. You can create a report here, but this report will be for only this column. So I will show you how to create a report for all the columns. Then lastly, you can go to elevation drawings. We have this pop-up. Click on OK. Now you will have how the reinforcement have been placed in your column. You can see it from the graph here. Good. So you can review how the column will behave. Yeah. So let's take a look on how to create reports, column reports. So after designing all your columns, okay, if everything is okay, now move to the report tab. We were under design, so if you go to the report, you'll be able to see these reports here. Reports. Then you can create design reports. But before creating design report or report table or any other kind of reports here, please note that a column which is ticked under the print column, you see we have print column here, all the column which are ticked will be reported, yes. Okay. So for instance, if I want to report only, let's say, this one column, I will make sure I remove all print marks. Then I will tick only one column. In that case, if I click on design report, I will have a report of only that single column. Okay. So if I check all and click on design report, so I will have a report for all the columns in my model. Okay. You see the total number of pages now 28. When creating report, here we have other report options. It's up to you. If you want to include load combinations, you tick them. If you want to include the interaction diagram, it's up to you to choose what you want to appear in a report. For instance, I will tick only one column, then I will make sure everything here is activated, so to show you the difference. Now this time in my report, I have the section, okay? I have these interaction diagrams because I have ticked everything. I have these load combinations, okay, in the report. Good. Yes. Yeah. Okay, you will see that after even creating a report, okay, you will have option to save it as a PDF or Microsoft Office. Okay, so it's good. So that's it regarding the columns. So let's move to the BIM now. Under design, go to BIM, story BIM. So engineer Romeo, I come into error card solver. So Romeo, we are done with analysis. So why are you still on analysis? Please go with the design. Okay. However, that error come to the under the building analysis. Okay. Under the setting mode option, settings, and check this spacer server. Okay. So if you uncheck this, then you no longer see that error. Good, Romeo, but please proceed with the design. Okay, good. So, Chad, you have some circular columns designed as square columns. Can it be rectified at this stage? I don't understand your question, Engineer Chedi. So, do you have a circular column that you want to change into a rectangular column? I'm not getting your question. Please clarify so that I can assist. Okay, so while waiting for the clarification for that question, I will proceed to the BIM. Okay. So for the BIM, go to the design, of course, then go to story BIM. Again, we will have a table with all the beams. As usual, we have interactive design, we have batch mode design. So we are starting with the interactive design. So maybe before I proceed with the BIM, there is something you must know. Remember that what we are using here in the design, okay, the settings we are using are default settings, okay? So I invite you all to have time, maybe after the training or when you find time, to go and investigate all these setting parameters. Okay. So as I have mentioned, because we are dealing with these two settings, Protastructure environment and Protadetail environment. So it deals with the environment of those two modules. Okay. The next one, from project preference to lateral drift and bracing. These are much more related to the analysis and things like that. Okay. Because you remember we have put the code, lateral adding and whatever, loading. So from the column and shear walls all the way to the assessment settings, this one in the middle, they deal with the design settings. From the scale here to plan details, these settings mainly deal with detailing. And lastly, the template management deals with the template settings. Okay, so when we come here to the design, for instance, if I start with the column, the one we have we were working on, if you expand the design, okay, of the column, you see we have different settings. As I click on one of these, you see the settings here are changing. Okay, so I invite you to have time and come and just double check. Okay, pass through all these settings, and if you meet some confusion, I will always be available online. You can just text me and I will give you clarification. Okay. For example, here there is someone who were designing. Okay. And it was clear that through the utilization ratio, okay, he can reduce the size of the reinforcement. But when he tried to reduce the size of the reinforcement, the column were failing. Yet it is clear through the utilization ratio that can be reduced. So for instance, the problem was that under the reinforcement here, under the longitudinal bar here, he had a setting that the minimum reinforcement in column must be 16. So if you have these settings, okay, and you try to use a diameter of 12, the software will not allow you to do so. So that's just a simple example I'm giving you. Okay. So you must have to double check these settings to see what is included. Okay. Another typical example maybe I can provide when it comes to detailing, for instance. Okay, let's say detailing. Depending on where you are doing your project, okay. Some are detailing the columns and having the rebar, this bob, this bending of bars here at the top of the column, having this shape, okay. Other detail using this shape. So here I'm talking about the detailing settings, okay. So if you choose this, when we'll be creating drawings, it will be detailed, the column will be detailed in this manner. If you choose this one, then it will be detailed in this way. Okay, so depending on what you are using, make sure that you set the right settings. Okay. Okay, good. That was just to give you information. Make sure that you will have time to go through the settings and double check. Okay. Good. So let's go on with the BIM. Go to the design. Go to Story BIM design. Select one BIM. and do the interactive design, so that you may have something like this. If you click on interactive design, you will have that warning saying that the design is not valid, okay, because we didn't design yet. So do you want to update the rebars? If you click on yes, then the software will automatically update the rebars. If you click on no, it means it's like you want to do it by yourself manually. Okay. So for my case, I'm accepting, click on yes. Then automatically you will see all the reinforcements have been placed according to the loading that I have on the beam. Okay, so in this time, if I click on OK, now the beam is passing, of course. Yeah, because the beam, if you have other span, it is analyzed as a continuous beam. It is one beam, but which is continuous. So that's why, yeah. Okay, so do the batch design, do the beam design using the batch design. We have those three options, you remember, the same for the column. I will select all bars and then calculate. Software will run the calculations, then it is done. If I close, all the beams now are designed. Okay. So try to do the batch design, then after let's take like 1 minute so that you can do the batch design. Now after that I will come back and together we will explore all these settings for the beam. So take 1 minute to do that. So Engineer Chedi, okay, so in the model I gave you, so those circular columns you are saying, it was a proposal from an architect, okay? So you as a structural engineer, you have right to decide if you are keeping the proposal from the architecture or if you are changing. So if the proposal are okay with your structure model, then you may accept. If it is not sufficient, you can advise and provide a more sufficient or accurate section, if I can say. So if you were asking if the circular column you had on the drawing, you can turn it into a square column, yes, you can, because where it is located, it is like in a wall, so it will not much affect. You cannot say that you will affect maybe the aesthetical design of the architect. Okay. So that's what I can say about that. So going to the beam, so you have all designed the beam here. So let's explore. Please take a look here. So for the beam, as you can see, let me take a simple beam like this. It will be much easier for you to see. If you check, we have this information here. So the first one, it is the area required. Okay, so it is very simple because every numbers here have its meaning on the left side. So this blue inside the BIM, it is the area required. Okay, so you can see we have information about the BIM label. You can directly know the supporting of the BIM, which are column 6 and 19 for my case. Okay. You can view the cross-section of the BIM, even the height of the BIM, the level of the BIM. You can view the axes which are supporting the BIM on the I and J end. Okay, so through the figure you have all the information. You can even see the span, all are there. Okay, so the next ones, they are extra reinforcements. Okay. Then next one, we see the minimum. We have the minimum area at the top and at the bottom. You can see. It means these black numbers represent the minimum area at the top and at the bottom. The next one, it is the spacing, okay, at the top and at the bottom. Following one is the deflection. Okay. The last one in the table is the distance for support link region, what supports. Okay, so those are the meanings of these numbers. Then lastly, all this we are seeing here, all this is the reinforcement. Okay. So for instance, if I come here and try to reduce, remove the reinforcement, you will see automatically I have some red colors. Okay. So by viewing these numbers in red, I will automatically know that I have issue of reinforcement. Okay. At the top side, because those numbers which become red are on the top. So it means the reinforcement issue is on the top. Then I can come manually and add top reinforcement. So if I click here, using the arrows on the left side, I can increase or decrease the number of rebars. So if I use the arrows on the right side, I can increase or decrease the diameter of the reinforcement. Okay, so you have two options. You can manually adjust the reinforcement like so, or you can simply click on select bars here at the top so that the software can perform an interactive design and provide the adequate reinforcement in the BIM. Good. So if I try to demonstrate this using a continuous BIM, let's say, let me see the appropriate one, like this one. Have many spans. Okay. If for instance, we have a scenario like this. Okay. If I click on OK, now you see my BIM is not passing. So I want to know why my BIM is not passing, the reason of failure. So I will select it and do the interactive design to open it. So I will click on no so that it will remain as it is. I will see I have these red numbers here on the bottom telling me that I have insufficient reinforcement at the bottom for this span, the first span. So I can click here on the bottom. You see the bottom bars. I want to add bottom bars, increase. Then you see the number, the red numbers will disappear. If I click on OK, still it is not designed, so I will again open it. If I scroll all the way to the right, I will see I have another issue for the reinforcement. I can again manually add reinforcement. Now in this case, if I accept, then the issue will be resolved. So it is always important to know why a member is failing. It helps to know what to do to rectify the issue. So the last thing I want to show on the BIM here, it is this rebar pattern, the rebar pattern. Okay. So if I open again the BIM that we had, and I go to select rebars, there is a drop-down menu. If you click on it, we see we have different patterns. So the patterns are the way are different ways reinforcement are arranged in a BIM. Okay, layers and even the cartooning. Okay, so for instance, if you take a look at the reinforcement here, if I choose the bend up one, for instance, you see how the reinforcement arrangement are changing here. If I choose, let's say, another pattern, standard pattern 3, you see how it is changing, and so on. So we have different arrangements. So it's up to you to know which pattern you want to use, because whenever you change a pattern here, even here you have information to know which pattern you have used. Okay. So I want to show you the difference between these patterns and how you can set them. So I will go to the settings. I can pass here. Even this is the settings button. I can pass here. You have the settings. Go to the BIM, because we are dealing with BIM, and you will see rebar pattern. Click on rebar pattern. Under settings, go all the way to the BIM, expand the BIM, you will see rebar patterns. So click on rebar patterns. Close and open the normal setting. Okay, so the rebar patterns that I was showing you are all here. You can see they are available here. Okay. So if you click on any given rebar pattern, you will see the arrangement here. Let's suppose you have one span. So you see the arrangement of the reinforcement in a BIM. Okay. As long as you change the pattern, we see how the reinforcement are arranged here. You will also be able to see the rebar type available within a pattern. Okay. Good. So I advise you to take a minute, maybe later, go through all these different patterns. Okay. Try to see the layers that are within a pattern, and decide which one will be used. So let's suppose maybe for my case, I have said I will go with bend up pattern, for instance, okay? So if this is the one I want to use, so I will have to select it, okay? And make sure I set the pattern as default. So if I do that, the next time when I will be doing the design of the beam, it will be using the bent up instead of the standard pattern 2 that we had. So I will click set as default, and I will make sure it have been updated here. So if I click on OK, now I have set my rebar pattern. So if I do the batch mode and reselect everything, I will have this dialog box. Okay, this warning telling me that I have changed the rebar pattern. So do I want to update that pattern? So yes. We calculate again, then we'll have it pattern applied. Now you see, now I have the method is bend up pattern instead of standard number 2 that I had before. Okay. So the last thing I will show you on a BIM, of course, is to create a report. After designing everything, if everything is okay, now we remember the BIM which are under print are the one to appear in the report. Okay. So if I click on a summary report, yeah, click OK. It will load. So pay attention. So as long as you have many beams, okay, as long as you have decided to tick everything here, the more it will take time to load, to generate the report. Okay, so for the demonstration of this, if you know that you are using a computer which is not powerful, just tick one beam so that you can see how it is working, but I don't advise to select all the beams. So now I have a report, okay, for all the beams. A very long report, a lot of pages, okay. A lot of pages because we have each and every beam that we have in our model have been calculated and reported, okay. And remember, this is just a summary report, okay. So if I try to open the detailed report, so I will only do it for one continuous beam. So if I click on the detailed report now to show you the difference between a summary report and detailed report. So for the detailed report, okay, you will have all the, of course, the information related to the loading on the beam. Okay, then we will have loads which are coming from the beam. We have those which are coming from the slab. Then we start the analysis. Okay, show you the diagram. Then they give you the parameters, the design parameters. Then we start designing the beam. Then when you start designing a beam, okay, here, you will be able to see that we have like references, okay? It's like a manual calculation report. So there, if they give you a partial safety factor, 1.5, they also show you the clause from the code that you have selected. Remember, we have selected the British standard. So in this case, partial safety factor for concrete is 1.5, and it is stated in this clause of the code. For the steel, we know that it is 1.15. They give you the statement from the code. So that's why it is called a detailed report. So they give you, you remember all these formulas to find the Q and the Z and even the enforcement. Okay, the moment they give you the formula they have used, they give you everything. So that's why it is a detailed report. So depending on what you want to produce, you have to check to use the summary report or detailed report accordingly. So here there is another report that me personally I do prefer using. It is the bar list report. Okay. So if I open this, you will have a table, okay, with all the beams and the reinforcement within the beams, okay. Table containing all beams with the reinforcement. It is also available for the column. If I go back to column, okay, under reports, we also have rebar table, very important. You have all the columns, for instance, column 1, the size, the area required, and then you have the reinforcement, even the shear links. So it's like a table showing each and every column. Very important report. Remember, you can always save as a PDF or as a Office document. So that's it for the beam. Again, if I go to the review to try to see how my model is changing, now that's the result. Remember, the green color meaning members are okay. So all beams are designed, columns all designed. I remain with the slabs, okay, the slabs. Good. So please take like only 3 minutes to double check. If there is something you want to double check, then I will go on and proceed with the design of slab. Please make sure that whenever after every member we are designing, you are trying to create the report, because at the end of the day, tomorrow, yes, tomorrow, sure, you saw that we have created the report for column. Now we have created the report for beams. We will create even for slab and so on. But at the end of the day, we have to have one report, a combined report. Okay, so we have to create a combined report. So to create a combined report, you must first of all create those individual reports. So on your softwares, make sure you are also creating reports as I'm doing here. So take any report that you want to have. Okay, let's see if there is any question online. No questions, so let's go for the slab. Okay. So we are going to design the slab now. Right. So slab are designed. Before designing the slab, you have first of all to model the slab strip. What we call slab strips. Slab strips are found in the modeling tab. Whenever you understand the word modeling, always remember it is in modeling tab. Under modeling tab, we have slab strips. Okay, so click on slab strip, and we will have the slab strip dialog box here. Good. So we have direction. I'm going to explain the settings here. Direction, we have direction X and Y. So you know the X direction, you know the Y direction. Okay. So then the following one is the number. It's just like a label of the strip. It will update accordingly as we are modeling the strips. The most important thing here is the type. Okay. Under type, you have 3 different type of strip. Okay. Have 3 different types. We have analytical strip. We have the finite element strip, FE strip, and we have also the manual strip. Good. Yeah. So it's important to know when to use which of these. Okay. So you will use analytical strip if you have conducted a building analysis as an analysis method. If you have used the building analysis, okay. You remember under the analysis for our case, we have used the building analysis method. So in that case, we will be using the analytical strip. So we'll use the finite strip if you have conducted the finite analysis. Okay, finite flow analysis. Okay, and we'll use manual strip if you want to do what? Okay, that's true. If you want to put the reinforcement by your own, but make sure you know what you are doing. Okay, because those reinforcement they will be put manually by you, the user, without considering the analysis results. So it means for our case we are going to use the analytical strip. Good. Another important thing here is to know the boundary conditions. The boundary condition. So the boundary condition, if you check well, we have at the start and at the end. The start and end we are talking about is the starting and the ending of the strip, where your strip is starting, where is ending. So we take one slab as an example. Let me take this as an example, this panel here. So I'm going to draw a strip in X direction. So let's suppose I only want to design only this panel, only this panel. So I will draw a strip in X direction. Okay. So in X direction, if I draw a strip in X direction, this will be the start, the starting point of the strip. This will be the ending point. In Y direction, this will be the starting point, the bottom one. This will be the ending point. You are already familiar when we are drawing, go from left to right and from down up. So it means you have understood the starting and the ending point. So now here we have three options. Continuous slab, okay. We have supported slab, and we have a cantilever one. This is the meaning. The first one here, this continuous. So what is continuing is the slab. Okay, so let's try to model the strip so that you can understand it more. So we are going to model a strip in X direction. So if I want to use this, okay, this slab, the strip must start outside of that slab that I want to design and end outside. Okay, this means you will start somewhere here, and the condition at the start will be continuous because we have another slab here. So the slab is continuous. So I will click continuous. Then at the end here, the slab is also continuous. So I will have to choose continuous. After defining this boundary, so all I have to do is to click, come all the way here. To make sure the line is straight, I have to hold Control, you remember? Then click. Now I have created the first strip in X direction, only for this panel. And if I try to zoom, you will see that reinforcement have been already directly placed, 10 at a spacing of 200. Okay, is X direction. If I wanted to put the reinforcement in Y direction, what will be the boundary conditions? Starting here, start, okay, continuous, the end, supported, this one in the middle, okay. Then I can go from here all the way to here. Now in this case, I will know that my slab now have the reinforcement from there. So it is very important. Let's take another example. I want to design this slab here and this slab at the same time in Y direction. Only this, because it is not mandatory to take one panel of the slab. I can even go from here to here. So let's suppose I want to design these three slabs at the same time. So I will go to the modeling, take the slab strip, okay. It is in X direction. I'm going to start in X direction. So starting here, the boundary condition will be the supported. Where I will be ending here will be supported. Then I can draw from all the way here to here. then I will be having reinforcement. Are you able to understand these boundary conditions? Because they are very crucial. So let's suppose I want to design this cantilever here. Okay? This cantilever here. It is in Y direction, right? Then the condition here will be cantilever good. And I will end the strip here. The condition will be continuous. Great. Then I can draw like this. And the reinforcement will be placed. Good. Can you try to do practice? Maybe you'll find some challenge and I will try to assist you. What you have to take into account that I wanted to mention, the reinforcement we are designing, those are only the main reinforcement, not the distribution bars. Okay, there are many reinforcements. So whenever you have one-way slab, it means we put reinforcement in one direction only. You will not always put the strip in X and Y direction. Yes. So X and Y direction, we put in X and Y when it is a two-way slab. But whenever you have a one-way slab, it will be in one direction, either X only or Y. So try, and I will be here to help if you meet any problem. Okay, so online people, is there any other question? If you have managed to apply the strip, so you will have it as an assignment. You will make sure that all the slab by tomorrow will be having the appropriate strip. But for now, you have seen how you can apply strips. So what we are going to do is just go and see how we can design the slab. Okay, find the calculation report and whatever. So it is under design. Please go under design. Now you see slab analysis and design. If you go to the slab, into the design tab, we'll see slab and analysis design. If you click there, you will be able to see the list of all the strips. Okay, I only have few because I didn't put strip on all the slabs. Okay, you may have more. Okay, good. So you can do the interactive design as we did for the remaining members. If I select one and do interactive design, then I will have like a summary of only that strip. Okay. If I click on design, you are already familiar with these three options. Okay. Yeah, before even doing this, the design status is passing because you remember when we were modeling the strip, okay? We checked that we are using analytical strip. It's like we are modeling, but the results are coming from the analysis already. So because we have already run the analysis, as long as we put the strip, the strip will be passing. The design status will be okay. Okay, so but I'm showing you this because sometimes you may find you have a strip, but the design status is wrong. So in that case, you have to do the interactive design and redesign again. Okay. Then to redesign and give you the reinforcement here. Good. You can also do the batch design if you have multiple strips which are not passing. you can do the batch design as we saw earlier, and then it will redesign everything. Good. So if you have design status as passing here, if everything is okay, it means the reinforcement in your slab are sufficient. Then you can create the design report. And you will have a report for all your reinforcement. Under the design report, you can see the type of the slab. Remember, you have changed type of slab accordingly. So, have type of the slab here. We have all the information, the height of the slab, the effective depth, okay, the maximum load combination used, okay, everything will be able. And at the end here, we'll see the area required versus the area supplied. Okay. And you will see also the deflection check as well. Yeah. You can save it as PDF for us, Microsoft Office. Good. Yeah, we are coming. Then I will close this. I will close this again. So in this case, I know that my slab have been designed. Okay. So talking about the settings, you remember the settings I told you that you should have to go through. In Africa, many people don't use this construction type of doing cantonment. Okay. So that's why you should go to the settings. If I go to the setting, go to the slab, okay, under rebars, under steel pattern, you see we have different options. We have this, the default one of cutting. We have this for bending, okay, of bend up. We have even this normal linear that most of us are using. So if I click on this, for instance, that's what I want to use, and click on OK. See, nothing have changed here. But if I select this strip, okay, and go to update steel bars, now you see it have been changed. The way this is aligned are different to I don't have any other example. Are different to the way these are arranged. Okay, you can see it here. If I go back to the way it was, select the strip, update. Now you see I have cut on it. At the support, yeah. These support rebars are not continuous. Okay. So it depends. So we have a lot of settings that are hidden inside. Yeah, so you must make sure that you take your time and review. But we have talked about the main ones. Okay. So so A and B have a question. Slab design report, it is only showing the dead load cases. Is it because I have not set live load? So yes, if you didn't set live load, then they will not be available in the report. Yeah. So that's it. That's how we can design column. That's how you can design beam and even slab. Okay. So the remaining parts you to do practices. Okay. And if I go back to the 3D view. You see the slab that I have designed now are green. Okay, those who are still white are the ones which are not designed yet. Okay. Good. So online people, I need to see your work. Online people, I need to see your work. So please, how are we going to do that? Just take a screenshot as usual, then send it to the WhatsApp group. Yeah. I just want to see how you have managed to model this, and tomorrow I will double check how you have managed to design members. But for now, I'm interested with the 3D model. So please send the photos in the WhatsApp. Okay, for A and B, I can see your work, Mariana. Okay. How about others? Shady, can I see your work? Even Daddy as well? Okay, A and B. So you have to continue and make sure that all slabs are designed by tomorrow. Okay. So for Mariana, the same. Make sure that all members are designed by tomorrow so that we can finalize the remaining tasks tomorrow with everything set. So Daddy, are we together? Even Chedi, I'm waiting for your work, please. So that it means you didn't work on the same model as we are working on. Can you please clarify this? Because I can see the model is different. So yes, okay, see tomorrow. Chedi, no, Daddy, I don't know why you choose to use another model, a different model, but please, I need to see the model we modeled because we started this model from scratch, the beginning, okay? So I don't know, I need to know the challenge you may face in modeling, okay? So please by tomorrow, try to model this, okay? And we'll see how it goes by tomorrow, right, Shady? I mean, Daddy. So, Chedi, how about you? Yeah, you are still working, but I need to see your model, please. Okay. Good, Daddy. Okay, so Chedi, can you take I need to see your model. Send the picture. Or I should stop sharing and you share your screen, so maybe if it is the easiest way for you. So for the remaining participants, A and B, Daddy and Mariana, so I can say that this is the end of today's session. We come back tomorrow morning, finalizing the remaining parts. Tomorrow's session will be mainly for the designing of foundation part, which is remaining, and also producing detailed drawing and reporting. Okay. So as you can see on the schedule, tomorrow, the last day, we'll be focusing on the path footing design. Okay. Then we go straight to the Prota details. Okay. And see how we can provide, or we can do the detailing of all the. Okay. How we can do the detailing of our structure, even reporting, and if times allow, also we'll see how the interoperability with Prota BIM. Okay. Then lastly, we close our training with certification. So that will be tomorrow's schedule. So that's it. I'm still waiting for Chedi's work. I wait for 1 minute. If there is no, if I don't get any feedback from him, then I would suppose that there is no work so far.